Good morning, students. In the previous sessions, you have studied about the first chapter, that is sets or set theory, we call that one. In that one, you learned the definition of a set, the notation, the representation, and the different type of operation, that is a union, intersection, difference, and many other things we have learnt under the chapter set. And also we have worked out enough number of problems using the particular operation, union or intersection or difference, and also complement of a set. Now, so we have completed the first chapter in the earlier session. Now I am starting the second chapter here, which deals with this one, that is, we call it as relations and functions. The second chapter deals with relations and functions. See, these words, relation and function, both these words, no, they are familiar to us. We use them in a general way. Relation and function. Function means we use, see, we have got a function at home, I have to attend a function, like that. So that is a different thing. That is a social gathering, I can say. Whereas function in mathematics is defined in an entirely different way. Similarly, relation. We say he is related to she has some relation. So we think about relation, the human relations we consider. And in this chapter, we are learning about the mathematical relations. Okay. But before learning about the relation and function, two concepts you have to study. First one is known as the ordered pair, an ordered pair. Now the word pair tells that there are two quantities. Pair means two quantities. A pair of things we say. That means there would be two quantities. Ordered pair. Order means, the word order says that it is in a particular order, particular way we have to write that one. So we call it as an ordered pair. That is the first word definition you have to know about. Now, of course, nobody asks you what is an ordered pair here, but you should know the meaning of an ordered pair here. Now, an ordered pair is a pair of elements. We call them as elements. In set also we call them as elements here. So, an ordered pair is a pair of elements written in ordinary brackets. See, in the earlier sessions, so while discussing about set, now I told, we usually consider four types of brackets: the ordinary bracket, the square bracket, the bar bracket, and flower bracket. So to denote a set, we were using the flower bracket, and any other, that is when you discuss about some algebraic expression and all, we sometimes use all the four brackets one after another. Now here, this ordinary bracket means it is like this, isn't it? And here we consider a pair of ordinary brackets. Inside we write two elements. It may be number or what are two elements, I am saying that all. So that's all. So this is called as an ordered pair. So an ordered pair is a pair of elements enclosed. We use the word enclosed in ordinary brackets, separated by a comma and written in a particular order. Now, here generally we express it like this: A comma B. If the same letter is used, I can write x1 comma x2, or a1 comma a2, or ab, bc, xy, z, something, any two alphabets we will be considering. So an ordered pair is a pair of elements or pair of numbers also we can say, but always we may not consider number. That is why in general we say an ordered pair is a pair of elements written in ordinary brackets or enclosed in ordinary brackets, separated by comma. That comma should be written there, and it is written in a particular order. For example, 2 comma 3 or 3 comma minus 4 or 5 comma minus half or 0 comma minus 3, something like this. All these numbers, no, we call them as ordered pairs. So this is the first definition we are learning. It is called as an ordered pair. Ordered pair. Okay. Now, in analytical geometry, or what you call as a rectangular Cartesian coordinate geometry, we have learnt about the coordinates of a point in your high school classes. that coordinates of a point, you can take it as an example for an ordered pair. There also, what is the meaning of coordinates of a point? A point can be represented with the help of two quantities, which we call them as the coordinates of a point. First value or first number tells it is the x coordinate, the second number gives you the y coordinate. So, the coordinates of a point, you can take it as an example for an ordered pair here. Now, here in general I write it as a comma b. A is called as the first element and B is called as the second element. Sometimes A is called as the first coordinate also. So, A is the first coordinate, B is the second coordinate, or generally we write A is the first element, B is the second element. So, this definition we have to know. Here under this one, I am giving you one information. With the help of that, you can work out some problem which can be expected just for a 1 mark question. Now, suppose you are having A comma B and B comma A. Can you take them equal to each other? It is not possible because I am using the word an ordered pair. Ordered pair means that order in which we write, that is also important. The numbers are same, no problem. AB we are having, BA we are having. The numbers are same, but the order is different. Therefore, A comma B cannot be equal to B comma A unless A is equal to B. If they are equal to each other, then I can write it as A comma A equal to B, A comma A, like that. When A and B are two different quantities, here A comma B in general cannot be equal to B comma A, or A comma B is not equal to B comma A unless A is equal to B. We can say like that. I will give an example. Now, suppose you take a point whose coordinates are 3 comma 4. Now, let me represent with the help of a diagram. Now, you know that when both of them are positive, both the coordinates are positive, the point lies in the first quadrant, correct? 3 comma 4. So, it is 1, 2, 3 somewhere here 4. So, this point is 3 comma 4. 3 units are here and 4 units are there. Suppose I interchange the numbers here, it becomes 4 comma 3. The numbers are same, but the order is different. 4 comma 3 means x coordinate is 4, okay, and y coordinate C. So, this becomes the point 4 comma 3. Clearly, you can see that there are entirely two different points. Therefore, in general, we can say A comma B can never be equal to B comma A. That is one thing. Now, sometimes we equate two ordered pairs. Suppose it is given like this. AB is equal to x comma y. A comma B equal to x comma y. What are they? These are two ordered pairs. If they are equated, in the problem itself, if they are equated, it is given like that, they are equal to each other, then you can equate the A to x here, that is the first element, what we say, the corresponding elements here, the corresponding first elements would be equal to each other and the corresponding second elements would be equal to each other. So, how do you say that one? Two ordered pairs are equal to each other if and only if. This we come across rather often in many concepts. If and only if. That means that this is true both ways. In short, we write it as IFF. That means we read it as if and only if. That is, two ordered pairs are equal to each other if and only if the corresponding first elements are equal and the corresponding second elements are equal. How do you write in notation? A comma B is equal to x comma y implies what are the first elements? A and x, and what are the second elements? B and y. So, you can write it. See here, 1 mark question you can expect on this one, which I am going to work out now. Here, any one of the position there may be an unknown quantity. If it is given that the ordered pairs are equal to each other, while equating the corresponding elements here, certainly you can get the value of the unknown quantity. So, that is you can expect for a 1 mark question a problem on finding the values of values of the unknown quantities considering the ordered pair here. Now, let me work out some problem here. The first problem is like this. If x plus 1 comma y minus 2, x plus 1 comma y minus 2 is equal to 3 comma 1, equal to 3 comma 1. So what you have to do here? You have to find x and y. Find x and y. Or there may be only one unknown quantity also, but generally it's for a 1 mark question, 2 unknown quantities would be there. So if x plus 1 comma y minus 2 is equal to 3 comma 1, find the values of x and y. Find the values of x and y. Now look here, two ordered pairs, just now I told you, two ordered pairs are equated to each other. What is the condition? The condition is you can equate the corresponding first elements and you can equate the corresponding second elements. So you have to write like this. See, this is a problem that is given. To solve them, you have to start like this. Given x plus 1 comma y minus 2 is equal to 3 comma 1. Equate the corresponding, or need not write, equate the first elements, or you can write corresponding elements on both the sides. First elements and the second elements on both the sides, on both the sides. So equate the, or the one word you can use, equate the corresponding elements on both the sides. Then what you will be having? First we will equate the first element, that is x plus 1. What is the first element on the right hand side? It is 3. Now let me come to the second element, y minus 2 is equal to 1. First step here, equate the corresponding elements, x plus 1 is equal to 3 and y minus 2 is equal to 1. Now you observe both of them are very simple equation. Now here x can be written as 1. When you take to the right hand side, you know that it becomes a negative number. So it becomes 3 minus 1. Therefore x would be equal to plus 2, 3 minus 1. Similarly, on shifting minus 2 to the right hand side, it becomes plus 2. Therefore, y would be equal to 3. That is 1 plus 2, 3. So if you write this one, usually it is given for a 1 mark question. So if you write this much, but you have to write this one. When I start like this, given like this, and equate the corresponding elements on both the sides, we have like this, x plus 1 equal to 3 and y minus 2 is equal to 1. Shifting the known number to the right hand side, keeping only the unknown number on the left hand side, we get the values of the unknown quantities. So it is generally asked for a 1 mark question. Now let me consider another problem of the same type. Another problem of the same type. Now here the problem is like this. If x plus 4 comma y plus 3 is equal to minus 2 comma 1, then find x and y. Find x and y. Now that is same type of problem as we did just now. Now start with the data, that is given x plus 4 comma y plus 3 is equal to minus 2 comma 1. So what you have to do? You have to equate the corresponding elements. What do you mean by corresponding elements? Corresponding elements means first element to first element, second element to second element. That is the meaning of corresponding elements. Equate the corresponding elements we have. See, many students, they don't have the habit of writing the statements in between. But many problems, no, it is required. We have to write that one. Simply if you do the calculation, some students do not write the conclusion, then they may lose the marks. So wherever it is needed to write the statements or the answer is in terms of a sentence, you have to write the answer in the proper sentence. That is, conclusive sentence should be written properly. Equate the corresponding elements. We have x plus 4 is equal to minus 2. That is the first element. The second one, y plus 3 is equal to plus 1. Therefore, we can take this 4 to the right hand side. Because it is plus 4, it would become minus 4. Already one minus 2 is there. So, since both of them are negative, we add them and give the same sign, minus sign, to the answer. So, x is equal to minus 6. Let me come to this one. It is y equal to, when 3 goes to the right hand side, it becomes minus 3. Now, plus 1 minus 3, we have to take the difference and then automatically it will have the sign of the bigger number. So, y is equal to minus 2. So, x is equal to minus 6 and y is equal to minus 2. So, these are the values of the x and y in the using the particular condition, that is by equating two ordered pairs here. Equating means you have to equate the corresponding elements, corresponding first elements and corresponding second elements. Automatically we will be getting the required value. That is in the place of x and y, you may have only one unknown quantity, x or y, anything. Generally two unknown quantities are given. Now in both these problems, I had given you whole numbers, integers I mean. Whereas in the next problem some fractional values are given. So be careful, you have to take the LCM and add. Now let me consider the next problem. If x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3. 5 by 3 comma 1 by 3, you have to get the values of x and y. You have to get the values of x and y. Now the procedure is same, the difference is you are not having integer, you are having some fractional values here, that is x by something, and here it is y we are having, but we are having some rational numbers in other words. So the same condition, first because they have been equated. When it is not so, we cannot get the value, because both the ordered pairs have been equated. We can equate the corresponding elements. Equate the corresponding elements. Equate the corresponding elements. Therefore, we have x by 3 plus 1 is equal to 5 by 3. This is the first element on the left hand side, this is the first element on the right hand side. First I will simply, yes, of course the other one also, let me equate. Y minus 2 by 3 is equal to 1 by 3. You observe here both of them will they are having the rational numbers here. So that is fractions I mean. That means that you have to simplify, you have to take the LCM for that one. First let me shift this one to the right hand side. That is x by 3 would be equal to, now this plus 1 becomes minus 1 plus 5 by 3. Whereas here y we don't have any fractional value with that one. Here 2 by 3 minus 2 by 3 would become plus 2 by 3. So both of them are positive, whereas here one is negative, the other is positive. Now let me consider the value of x first here. That is x by 3 would be equal to, look here, minus 1 means it is minus 1 by 1. I can write like this, minus 1 by 1. That means 1 is the denominator, 3 is the denominator. Hope remember how to take the LCM. For 1 and 3, the LCM is 3 itself, the least common multiple. So 1 3s are 3 into minus 1 is minus 3. 3 1s are 1 into 5. That is, we divide the LCM by a denominator. Then whatever number we get, by that we multiply the corresponding numerator. Now here we are having plus 5 minus 3, that is plus 2 divided by 3. So it is x by 3 equal to 2 by 3. So here you can directly cancel 3, hence what we are having? We are having the value of x to be equal to 2. So the value of x in this case is equal to 2. Now let us come to the second part, that is the value of the other unknown number y. See, look at these numbers. See, without taking the LCM also, you can solve this problem. That is, if you could remember, otherwise the other procedure is there only, that is taking LCM. See, 2 by 3 plus 1 by 3, 1/3 plus 2/3. When you add them, what you'll be getting? One thing. That is only the number 1. 2/3 plus 1/3 will become 1. But if you find difficult, the usual procedure is there, you take the LCM. In this case, 3 being the common denominator for both the numbers, that itself becomes a LCM. So 3 ones are 1 into 2, 3 ones are 1 into 1. So that would be 2 plus 1, 3 divided by 3, and 3 and 3 they get cancelled. If cancel means it is not 0, we will be having 1. So the value of y is 1. So though in the problem we had the fractional values, we could we have got here for x and y only the whole numbers are the integers here. Now this is the procedure we adopt to get the values of x and y when two ordered pairs are equated. Okay, when two ordered pairs are equated, we will be equating the corresponding elements, first elements as well as the second elements, then we can get the value of the both the unknown quantities. Let me have another problem. 2x plus 3 comma y by 4 minus 1. If this is equal to, this ordered pair is equal to 1 by 4 comma 3 by 7. Some number. So here the both of them are containing unknown numbers, they both of them are known numbers. So here also I am considering some fractional values. So let me equate the corresponding elements, that is this implies that, you have to write that sentence of course, equating the corresponding first and second elements. 2x plus 3 would be equal to 1 by 4, that is the first element on the right hand side. Then y by 4 minus 1 equal to 3 by 7, which is the second element on the right hand side. Now here, that is 2x equal to, shift 3 to the right hand side, which becomes minus 3. Minus 3 plus 1 by 4. Now again minus 3 means you can write it as minus 3 by 1 for your convenience, though it is not necessary. For 1 and 4, 4 is the LCM. So 1 4s are 4 into minus 3, that is minus 12. 4 1s are 1 into 1, that is 2x would be equal to minus 12 plus 1 divided by 4. First let me simplify that one, that is 2x would be equal to minus 12 plus 1 is minus 11 by 4. Now it is little bit different from the previous problem. Now when 2x equal to minus 11 by 4, x would be equal to, this 2 comes to the denominator position, that is 4 into 2 here. When you are multiplying, when you take to the right hand side, it goes to the denominator position. Hence we are having x to be equal to minus 11 by 8. So it is a negative number, negative rational number. Now come to this one. Procedure is same. Y by 4 equal to, take 1 to the right hand side, it becomes minus 1 will become plus 1. Now it is 1 means it is again 1 by 1. So when you take the LCM for 1 and 7, 7 is the LCM. 1 7s are 7 into 1. 7 1s are 1 into 3. Therefore we are having here y by 4 would be equal to 7 plus 3, 10 divided by 7. Now see in this case, now 2 was in the numerator, when you took it to the right hand side it went to the denominator, sort of cross multiplication. Here 4 is in the denominator, so when you take to the right hand side 4 goes to the numerator. So it is 4 into 10 divided by 7, you cannot do any cancellation, so it becomes 40 by 7. So in this case also we got a fractional value. So if it is, sometimes it may be positive, possible to do some cancellation. Suppose we had a number here 8 or 12, then you can do some cancellation, otherwise it is not possible. So this is the procedure we adopt. So an ordered pair is a pair of elements written or enclosed in a pair of ordinary brackets separated by a comma and written in a particular order. in working out problems, so many ordered pairs we come across. So when we use the word ordered pair, be careful, the order is important here. That is, you have to write in the same order. 3 comma minus 4 is entirely different from minus 4 comma 3. If you write 3 4, you have to write 3 4 in all the places. If you interchange the number, not naturally it will be a different, altogether a different ordered pair. Therefore, the order is very important. Now, this is the first definition, and here this relation function, everything depends upon the set only. That is why I had taught you about the set in the earlier chapter. Now, it is a continuation of that one. So, an ordered pair, now here we are taking now to define relation, and then I define about the function and all. Then I will be taking up that in the next session, where I will give you the definition of a relation. Again, before the word relation, before you know the definition of a relation, we are going to learn another concept which is called as the Cartesian product, that I will take up in the next session. Thank you.